All right. We will be getting started in just another minute. Okay, welcome to Spark App League Teacher Training Session 1. For this session, we're going to be recording this on YouTube Live. So if you don't get a chance to make it for this session, you can always watch this afterwards. Otherwise, we have 2 other sessions that are scheduled for this week, and then a couple more sessions scheduled for the next 2 following weeks prior to our competition. You can check out all of that information at sparkappleague.com/teacher-training. So that's sparkappleague.com teacher-training, and that'll have the schedule along with all the links available for each teacher training session up at the top of the page. So I'm going to give a few more minutes, maybe like 2 or 3 minutes, just for people to finish joining. I've got some people just viewing on YouTube. That's cool too. If you want to participate though, please make sure to click the Google Hangout link, and then you'll be able to ask questions during the broadcast and chat and do everything else, and people will be able to see your participation. So a couple more minutes and then we'll get started on the lesson. If you're waiting, you can go to scratch.mit.edu, and that's where we're going to start our training, right on the homepage of the Scratch website. So I'm going to pull that up now, and then we'll get started in just a minute. Okay, so our first lesson today is going to start with Scratch. So for our beginner level students, our competition uses Scratch from MIT, which is a great way, in my opinion, to introduce students to the concepts of coding. And one of my favorite things about the Scratch platform is that you can really do some seriously cool things with it. It is a complete programming language, so it's got all kinds of ways to do a lot of the concepts that you'd find in any written programming language. But the part that I like the best is it's all drag and drop. So we're going to start by going to scratch.mit.edu. If you'd like to, you can always sign up for an account on Scratch, which I would recommend doing. If you go up to the top here, I'm going to sign out really quick, but if you click this link that says sign in, that link will allow you to log into an existing account, or you can click join Scratch and it'll ask you some questions like your email address, set up a user account. The reason that we recommend that people set up an account when they're using Scratch is because both during the competition and during teacher training, you might want to come back and pick up where you left off or expand on something afterwards. And it will obviously slow you down if you have to start from scratch every single time. Now, during the competition itself, we do not allow students to use existing accounts. So we'll actually have some parameters for them to create brand new accounts at the competition. And that's just so that they don't create any kind of games or anything ahead of time. They also won't know the theme of our teacher training event. So until the students are given the theme, it doesn't really benefit them at all in any way to go in and create an account and set things up, because they'll need to redo everything in their brand new account. So I would create an account, that way you can save your progress as we go through these teacher training sessions. And then if you have any questions, feel free to message us. We've got a chat open on the YouTube live page. And then there's also, if you're part of the Hangout, feel free to join that. And you can ask your questions directly during the lesson. So again, the address for that is sparkappleague.com/teacher-training. And to start, we're just going to go over the Scratch user interface. So the first thing we're going to do when you're logged into the site is you click the Create button up here in the top left-hand corner next to the Scratch logo. And when that pulls up, you're going to get a kind of full screen interface. It'll only take the size of your browser window, so it's not really full screen, but this is basically the Scratch editor. And you should see 3 separate sections of the Scratch editor. So the first one is this area up in the upper left-hand corner. You'll see a little orange cartoon cat in the upper corner here. That's Scratch the cat. That's the Scratch mascot, if you will. So Scratch is basically, the mascot for this program. And so if you see him anywhere, that's probably related to this Scratch tool. And the stage is basically where the games that your students create, the apps that they create, this is where the live version of the app will be seen. This is exactly what a third-party person that comes in and opens their project, this is what they'll see. This is where you actually play the game. Now, this stage is set up so it's kind of, if you go back to math in kind of school, you'll see XY coordinate grids. So Scratch is set up on an XY coordinate grid. And all that means is if you look in the bottom right-hand corner of the stage, about halfway up your screen here, there's some numbers that keep changing and they'll have an XY here. All that means is that the very center of this stage, if I can move my mouse to it here, the very center of the stage is 0, 0. So if I move pretty close to where Scratch is, that's the exact center of the stage here. Oh, I just missed it. This is the exact center of the stage right here. So there you go. So that's 0, 0. So 0, 0 basically just means that if you want to see where something is from top to bottom, the Y numbers will go up as you get closer to the top of the screen, and then they'll go to 0 as you hit the middle, and then go negative as you go down to the bottom of the stage. Then from left and right, you'll have negative 240 all the way to the left. As you move to the right, you'll get 0 and then all the way back to 240. So it's negative 240 to 240 going from left to right, and then 180 to negative 180 going from top to bottom. And all that means is that when we go to create our games and we need to position our characters and our objects and the different pieces of our game, we can use those coordinates. We can use those numbers to position stuff. If we were to draw a graph on here, you'd see those exactly. The second part of our stage is the top banner here, which the first part is just where you name your project. That's not that big of a deal, as you can name it whatever you want. It's not unique to each project, so you can type whatever you want in there. But then there's these two buttons, the green flag and then a red stop sign. And these are very, very important because this is how we actually run the programs that we're creating. So as we start working on these games, you're going to see the green flag. You're going to click that anytime you want to start your project or the project that you're working on. And then if you click the red stop sign, that will stop your project to, stop it from working. So the stage is kind of where all the action happens. Now, below the stage, we have the second section of the Scratch window, which is basically the sprite window. And the sprite window is essentially where each object is in our game or our app. So all that means is sprite is just a fancy word for the actual art that accompanies that. So as we start making these games, you're going to see this will start to make a little bit more sense to you. But every item in our game, whether it's a character or a power-up or an enemy, if there's if there's enemies in there, any kind of interactive item that's in maybe a level that the students are working on, or each different piece of an invention, all of those things are objects. And in Scratch, we call objects sprite because every object has to have a piece of artwork assigned to it. And that art is something that in the game world, they call sprites. A 2D piece of art is called a sprite. So right now, if you look down at the sprite window, we only have one sprite here, and it's sprite 1. It's Scratch the cat, and that's the same cat that's up here in our stage area. And the sprite area has a couple different sections, so we'll walk through them one at a time. But the big thing is that for each object that you have in your game or your project, you can add new objects or you can edit existing objects. So we're going to start with the add tools, and that's just these right here. We've got new sprite, and there's 4 little icons here. You should be able to see them highlighting in the window as I'm kind of mousing over them. And they fall under 4 types of ways that you can add a new object or a new character or whatever to our game. So we're actually going to do this later on, but I just want to show you because this applies to any type of thing that you can create or add, any type of object that you can add in Scratch. So the first one is creating it from a library. And all that means it looks like this little dude with kind of a mohawk and maybe some ears or a funky hairstyle. If you click this button, basically what you're going to get is the Scratch library. And the Scratch library work that you're allowed to use on all your games. It's all royalty free, copyright free, so it's completely usable in your games. When you come to a Spark App League competition, we don't put any kind of restrictions on the artwork that you can use, but if you plan to share your game outside of our competition, or if your students want to show it off on their website or anything like that, they have to use royalty-free images. So this is an easy way to get to those. You can also do Google searches for royalty images, or there's websites that specialize in royalty-free, both cartoons, stock photos, items, pictures, and there's even some that are specialized in video game objects or video game characters. So feel free to use those, but just remember that you can't show those if they have some kind of copyrighted or trademark imagery. Okay, so you click that button, you can select your item and then just hit OK, and that will add that item to the stage, which again, we'll get to later as we start making our game. You can also paint a new sprite, and all that does is that opens up this third area here, which we'll talk about in a sec. But that creates a brand new sprite for you and then gives you kind of a little basic paint program to paint things in. Delete that just so we don't get confused here. You can also upload objects or images for those objects from a file. So if you already have something on your computer, you can click that item there and it'll open up the window to browse your computer so you can find files. And then the last one is using the webcam on your computer. If you're using a computer that has a webcam or some other kind of camera plugged into it, you can click here and Scratch will try to take a photo from whatever whatever your item is. So whether it's your face, or if you want to take a picture of a character that you're using or an action figure or something like that, you can do that with the camera. The other part is the sprite window also has those same 4 buttons down here, but these relate to what's called the stage. So we already talked about the stage up here, and this works exactly the same way, except the stage itself is actually its own object. So every single game or app that you create in Scratch will always have a stage. And so because of that, you can also change what the stage looks like. And again, you can do it from a library, you can paint it, you can upload your own files or use the camera. And these are just basically backgrounds. You can assign a background to the stage instead of just being plain white. You can assign a background to it, or upload a background to it, or paint a background to it. So that's in the same section because it's technically an object, but it's separated from the rest of the objects in the game because you can't add a new stage. You can add multiple backdrops to it, but there's only one stage per project. And then you can't delete the stage either. If you wanted to delete the stage, you'd have to either delete the whole project or delete all the items on the stage, all the other sprites, all the other objects, to basically start from scratch. You can remove backdrops, but again, the backdrop is just the visual representation of the stage. So that's our sprite section. So again, just to recap, we've got our stage here, which is where the action happens. We've got our sprites, which are all the objects in our game. And again, that can be everything from a ball, a car, to an enemy, to a power-up, to the characters in our game. Any type of object that you will be writing code for will be a sprite. And that takes us to our third section, which is the actual code window, or the workspace, as some people call it. So the workspace consists of 2 separate areas. One is this small, thin strip in the middle of the screen that has these 3 tabs up at the top, which say scripts, costumes, and sounds. We are mainly just going to focus on the script section, which are all of our code blocks. But you can also change the way that your characters look, or that sprites look here, again, using that painting interface that we talked about when we talked about the sprites. And then there's also sounds that you can add. We're not going to focus on sounds, but I'll show you some resources in a little bit that will show you where you can find out how to use those. So for now, we're just going to focus on these script blocks here, and I'll cover more. The second part of this is the actual work area or workspace itself. And it's this giant empty gray area here to the right-hand side. The only things that it has are a little picture of the current sprite along with the XY coordinates. And then down in the bottom right-hand corner, you have a minus sign in a magnifying glass, an equal sign, and then a plus sign in a magnifying glass. These are just your zoom controls. So as you start working on your project, you're probably not going to have too many blocks, and it's probably not going to be too unmanageable. But as you get more and more code blocks built in Scratch, you're going to need to zoom in and out to be able to see some of those and kind of navigate around where the different parts of your program are. So this work area basically works in the way that we simply take the blocks that are here on the left-hand side, and we drag them into the work area. Okay, so now this work area means that this code here, this move 10 steps, is now in our code area. Okay, so again, those 3 sections are the stage, the sprites here, and then this giant work area, which is where we're going to spend the majority of our time coding. And then as we update this area, we'll see the stuff in the stage update. So our first step here is basically to create a very, very basic game in Scratch. And all our game is going to be is Scratch the Cat here is going to catch items as they fall from the top of the screen. And some items will be good, some items will be bad. We're going to start just by figuring out how to get Scratch the Cat to move around. Then we'll work at creating the actual items that fall from the top of the screen. And then we'll kind of just layer our project little by little. As we layer this, I'm going to introduce both programming concepts and Scratch specific concepts. And I will try whenever possible to make the distinction about whether or not something is a programming concept or whether it's something that's specific to Scratch. Okay, so the other thing I'm going to do is I'm also going to intentionally make certain mistakes throughout this process. So if you've used Scratch before and you know how some of this stuff works, I will intentionally be putting in mistakes in this project while we're working on it, because in a lot of cases, there are things in any programming language that feel like they should make sense or that feel like they should work based on the way that you've set them up, and sometimes they just don't. And Scratch is one of those programming languages, just like any other, where you might think you got something right and then it didn't exactly work the way that you wanted it to work. So we're going to intentionally make some of those mistakes, and then I'll point out when those mistakes happen and why they happen, and they're kind of the gotchas of learning how to use Scratch. So first, we're going to start off by taking Scratch the Cat and just adding some basic movement to him. Now, this isn't going to be player inputted movement, so you're not actually going to be playing anything. We're just going to get Scratch to move around the screen so that we can see the basics of how the Scratch system works. So the first thing I'm going to do is take Scratch the Cat here. And while I'm in this editor view, you can drag around any object that you have in your stage. Okay. And what happens, what you'll notice is that as I'm dragging it around, when I let go of the mouse, that character stays there. Okay. And when I click to drag the character, they get kind of like a drop shadow, which means I've picked it up and I'm moving it across the stage. Okay. And as I mentioned a few minutes ago, we have these blocks here on the right-hand side that basically are our code. They will control how Scratch the Cat works. So the first thing I want you to pay attention to is every single time you click on one of these different categories up at the top here, motion, events, looks, control, sound sensing, so on and so forth, you'll get a brand new set of blocks. And I see this happen every time with Scratch beginners. Don't just look through the list, or don't just jump down the list to try and find the item that you want. Go through each of the items in that category one at a time and see if you can figure out how they work. Okay, I'll give you a little cheater's guide in a little bit that will tell you exactly how they work, but it's good to kind of get into the habit of trying to figure out how some of these blocks work, just to kind of make that logical sense of how Scratch as a programming platform works. So we'll start with that first block that we dragged in. So if I drag in the move 10 steps block, how do I figure out what this does? Okay, and there's two different ways that you can do this. One is you can just double click on that block either here in the work area or here in your scripts panel. So if I double click on that, what's going to happen is my object, which is the only one that I have right now, Scratch the Cat, will perform whatever that action is. So as I click move 10 steps, Scratch the Cat will move 10 steps. Okay. He, in this case, will move 10 steps to the right because that's the direction that he's facing. But then our next block says turn with a little curved arrow 15 degrees. So if I click that a couple times, that'll move Scratch the Cat, and then move 10 steps will move him in that direction. Then we also have the ability to rotate him in the other direction, move 10 steps. And each time you double click, that block action will basically take place. Okay. The next block that we have is the point in direction. That just points the character in whatever direction we say. So we're going to point 90 degrees to the right. That gets us started. We're going to skip some of these other ones. I just want to point out that there's also a go to block where you can tell that object to go exactly where we want it to go. So as I mentioned, our coordinate grid has 0, 0 right in the middle here. So if I change this to 0, 0 and then double click on it, Scratch the Cat will jump right to the middle of our screen. Okay. So there's a couple others on here that you can use if you want to try to go through each one of them. You're more than welcome to. The second way that you can figure out how these blocks work, which is quote unquote my cheat guide that I mentioned earlier, is if you move your mouse all the way to the right-hand side of the work area, there's a little tiny question mark up here in the upper right-hand corner, and that'll open up the help file. And the help file has a tab up at the top that says blocks. And this will show you each of the blocks that's in each one of these different colored categories in our tab here. and then it'll tell you exactly what that block does. So if you click on it, it'll show you what the block looks like. It'll show you an example of how it's used, and then it'll give you the information about how that block actually functions. So we're going to do that a little bit more interactively. We're going to learn what each of these blocks do as we move through making this project. But the reason that I wanted to point out the go-to block at this juncture is because I mentioned that you can drag this character around. And one of the things that you'll notice is as you drag the character around, the go-to block actually automatically updates with the current position of that object. So a lot of times, both students and teachers will try to manually figure out by typing in the numbers, they'll try to figure out where or how to best position a character. The easiest way to do it is just click and drag that character where you want them. So in this case, I'm going to drag them to the top left, and that gives us the exact spot where we want that character to go. So now I can move that. Okay, now right now I've just got these disjointed blocks. Our programming is actually just going to be very similar to writing a recipe. So really that's all that programming is. Programming is just writing a recipe for a computer in a way that a computer understands. Now, the problem with computers is that they do exactly what you tell them to do in the order that you tell them to do it. So if you're missing any specific instructions, or if you're not specific enough, you might get some unintended consequences. So it's always important that when you're writing this recipe, you know, take the time to slowly walk through each step of your recipe and get it to go. Okay, so first let's write the recipe for Scratch the Cat. All I want Scratch to do is walk from where he is right now to the right-hand side of the screen, turn, walk down, turn again, walk to the bottom left-hand corner, and then turn again and walk back to the top so that he's facing in the same direction that he started. Or she, I guess Scratch could be a she too. So what we're going to do is we've moved Scratch the Cat. So our first step is just going to be to always start our program, always start Scratch the Cat moving in that upper left-hand corner, which when we dragged around, we determined it was this 191, 127, negative 191, 127, because that's negative 191 items or units in the X direction, and then 127 degrees up in the positive Y direction. So Scratch is going to jump to that spot. Then we want Scratch to move a couple steps. So I'm going to say move 10 steps, 10 steps, 10 steps, 10 steps. I'm going to have Scratch turn, and you can either, again, use the turn option and type in the amount, or you can just point Scratch the Cat in that direction. I'm going to turn him 90 degrees so we can use it the same way each time. Move another 40 steps, and then turn again. And when we're done, we should have Scratch the Cat moving all the way around the screen. Back to the start point. And then lastly, this time I'm going to point him back in the 90-degree direction so that he's right back up. But we could also turn him 90 degrees as well. Okay, so now we have our recipe. It's a pretty simple recipe. It's going to go to that top left corner, move 40 steps, 10 steps at a time, turn 90 degrees, move 40 steps, 10 steps at a time, and repeat that until he gets back to the starting spot. Now, in order for this program to actually run, in order for this code that we've created to actually run, we need to tell our program to run this when we click the green flag, okay? And clicking the green flag means go, but our object here doesn't understand that concept. It doesn't know that that means go, because clicking the green flag isn't the only way to get an object to create an animation or to do some kind of procedure, to do some kind of code. So if we go to the tab that's right next to the motion tab, which is the events tab, there is a special event block that just says when green flag clicked. And if I drag that to the top of my code block, my little recipe here, all I'm doing is telling this object, this character, that when I click the green flag, do these steps. And there's a couple other events here that we'll get to as we work on our program. But for now, we're just going to use this one. But just so you know, you can also make the recipe go when you press a key or when you click on that sprite or when the backdrop of our stage, like we talked about at the beginning, when that changes to a specific backdrop. There's also some other messaging that you can create, which we'll talk about a little later. But for right now, all we need is this when green flag is clicked. So when the green flag is clicked, we follow these steps. And when we hit the green flag, we should see Scratch the Cat do those steps. So if you look, all it looks like that happened is that Scratch basically shifted a little bit. And if I keep clicking the green flag, stopping it, clicking it, stopping it, it doesn't really do anything. And so you might think that our program isn't working or our code's not working. And this is exactly why, as I mentioned, the computer will do exactly what you tell it to do in the order that you tell it to do it. And so what happens, or what's happening here, is that Scratch, the program, is going, when we click the green flag, it's going through this and it's making Scratch the Cat do all these steps, but it's doing them all in order insanely fast. It's just going through and doing all of those things in that order immediately. So if you look, if we were to move Scratch the Cat and click the green flag, it'll change. It'll go back. It'll do the things that we said that it was doing, but it's doing them in that order. Okay, so a lot of the times this will happen where you think you wrote something correctly, you wrote a bunch of blocks of code the way that they should be written, and then it just doesn't work the way that you thought it works. And so all that means is that your project is taking what you've said literally, and you need to potentially change a few things on there. And again, I'm going to cover a few of these types of gotchas, but the easiest one is this one, is just the immediate execution gotcha, which just says that when you start your program, unless you've told the computer to wait for something, it will explicitly do all that stuff as quickly as it possibly can. So we have some other blocks here in the control section, which is underneath events, that give us a block that allows us to wait for 1 second. So if we add a bunch of these wait steps, you'll see this change a little bit. And I'm not going to add them all through this, but again, I'm just making the point that unless you told the computer to wait for something before going on to the next step, it's going to do all those steps insanely fast. So it did these first 4 now, these move 10 steps that we added the wait 1 second. But then as soon as it got to this turn 90 degrees, it did all of those right away. And then Scratch the Cat, instead of moving, zooms right through them really, really quickly. Okay. So as we're working on our game and making our program, we need to be careful and be cognizant that things happen all pretty quickly when it comes to the computer. So just make sure that when you're working on your games and creating this stuff, that you're keeping that in the back of your head and that you're kind of delivering that message to your students, because that's one of the biggest issues that we see with any of the code blocks in our competitions, is that students expect something to happen, and it is happening, but because they don't see it happen, they think it's not happening or that something's broken. So that's the first thing you want to check. Now, we've got this big long chunk of code. Now we're actually going to work on getting Scratch to move when we press some keys on the keyboard. So in order to get rid of all these code blocks, there's a couple different ways we can do it. You can right click on a code block and delete it. Okay. Caveat of that is that if you have a code block and you delete it, it also deletes any code blocks underneath that code block. So anything that's connected to that code will be deleted. So notice if I delete, for example, this turn 90 degrees, the ones up above it are fine, but anything below it gets disconnected because we've now disconnected that top one. The second way to do this is to just grab those blocks and drag them back into this middle section here. And when you let go, they'll disappear and those code blocks are deleted as well. As you probably just saw, there is an undo. It's very limited, so I wouldn't rely on the undo functionality, but you do have undo functionality here in the edit menu as well. Okay, so now based on what we've started, let's get Scratch the Cat in the bottom of the screen here. so that we can start to control him to move him left and right. So just like a regular Mario type video game, we want Scratch the Cat at the bottom of the screen here, and we want him to be able to move left and right. So we're going to position him there, grab our go-to block. I'm going to change this to 0 so that he's right in the middle. And then now if we put that on there, no matter where we drag him, he'll always start in the middle of the screen facing that direction. Okay. I also like to add the point in direction block just to be explicit that when my game starts, I want Scratch the Cat to go to that specific spot, but I also want to make sure he's pointing in the right direction. So I always add that block. And then that starts our game here. Now, we talked about some of the other event blocks, and we mentioned that there are blocks for when keys are pressed. So that's where we're going to jump to now to create the basics of our motion in our game. Okay, I'm going to show you another method for creating this motion later, but this is probably the easiest method to do this. So we'll start with the when space key is pressed, and you'll notice that the space item has a little drop down arrow here that we can click. So I'm just going to change this so that if I click the left arrow, I want Scratch the Cat to point left, which would be -90, and then move 10 steps in that direction. Okay, now, one of the things that you'll notice is that these steps will happen every single time that I press this. And you might not think that that's necessary because if the character is already pointing to the left, for example, we don't need to rotate them again. But it's easier and quicker to just consolidate this because if he's already pointing in this direction, then pointing him in that direction again will do nothing. But if he's not, that guarantees to us that Scratch the Cat will flip to the direction that we want him facing. So that's going to be our first one. Next one, we're going to do the same thing for the right arrow key. Now, in this particular game, we don't have any up and down movement, but this would be exactly the same way that you would make the up and down movement just by changing the direction that you're pointing Scratch the Cat. I'm going to say point in direction, move 10 steps. So now what you should see is that when I start the green flag, when I click the green flag, Scratch was already in that spot. So again, clicking it resets him. But now if I press the arrow keys on my keyboard, Scratch does in fact point in the direction that we hit the arrow keys, but then moves 10 steps in that direction each time we press it. If we hold it down, it moves it down. Now, obviously, there's, again, a gotcha here. There's a little issue. And that's that we haven't actually put in any kind of rotation for Scratch the Cat. I mentioned this earlier that we would get to editing these objects later on in the lesson, so we're at that part. So this is obviously wrong. When Scratch moves to the left, we don't want Scratch to flip upside down. We just want Scratch to move left and right. So basically to mirror on the left and move to the right. And all those types of options are set for each object. So each object that you add to your game has the ability to move left and right, move 360 degrees like Scratch is moving right now, or to not move at all, or at least not rotate at all. So if we go down here to where our object is, our sprite, Scratch the Cat is highlighted right now, and there's a little white eye and a blue circle to the top left. That's our information about that sprite. And if we click that, we see a few things. We see the name of the sprite first, which I'm going to go ahead and rename to Scratch the Cat. And then we have the direction that Scratch is currently facing, which you can set that direction here, but just remember that your code may be changing that direction. So this doesn't do much unless the object that you're putting in isn't going to be changed by code at all. We have rotation style, which means exactly what we were just mentioning, that the object can rotate 360 degrees. It can only rotate left and right mirrored, or this little dot, which means that the object doesn't rotate at all. So you can choose for this particular game either of these two options. If you want Scratch to move left, but you don't want the actual drawing to change, then you can set this dot, basically, which is static. Or you can change the left-right rotation, which will mirror our character depending on which direction Scratch is moving. Okay, so I'm going to leave it as left and right rotation, only along our x-axis. Can drag in player. This is an option we're not going to touch much on here, but Scratch also gives you the ability to create games where you can use the mouse to control what's going on the screen. And this option just tells Scratch that the player, whoever is playing this game, should be able to drag that item on here. So right now I can drag Scratch the Cat around because I'm editing this game. I'm the actual editor creating this. But players won't be able to do that. A player won't be able to take their mouse and drag Scratch around the screen, because in some cases that might break your game or it might stop your game from working. So this is where you would set whether or not you can drag that player. And then the last option is whether or not we can see that object. Okay, so whether or not that object is shown. And there's a couple ways to do this. We're not going to touch this much in our project, but just know that that also exists. Okay, so now, because we fixed that rotation, our program now should function pretty normally. If we press the right arrow key and hold it down, Scratch will move to the right until he gets to the edge of the screen. If we hold down the left arrow key, Scratch will move to the left until he gets to the edge of the screen. So we've got some basic movement figured out now. Okay. All right, now just for the sake of making this an actual game, at this point, I'm going to change the background of our stage so that it's a little bit more visually interesting and it's not just Scratch on a plain white background. So I'm going to move down here to our stage area in the sprites area, and I'm going to choose a new stage from the library. So let's see what we got here. I like the chalkboard because we're in a training session. Chalkboards are cool and old school. So we've changed the backdrop now. Again, nothing really in our game has changed except for the background now looks different from what it looked like before. So now Scratch is just walking back and forth, pacing in front of the chalkboard. Okay, so far so good. I'm not seeing any questions right now in the YouTube Live window, and so I'm going to continue on. I also don't see any questions or anything in our chat in the Hangout. So I'm going to keep going, but if you have any questions at all, feel free to stop me just by typing something in the chat, or if you're planning on joining us for the Hangout, you can always interrupt me. Okay, so next up, we need to actually create our objects that are going to be falling from the top of the screen. So this is going to work very, very similarly to games like Space Invaders or some of the older classic games where just an item drops from the top of the screen little by little, kind of Tetris style, where it starts at the top of the screen and drops down to the bottom. And later on, we're going to add it so that if Scratch the Cat catches that object, meaning he just touches it, that means that Scratch has caught it. You'll get a certain number of points for that object. Or if it hits the bottom of the screen, it'll disappear and the player will either lose a life or we'll add some kind of interactivity to that. But for now, we just want to add an item that drops from the top of the screen and goes down to the bottom. So the way we'll do that is we need to add a new object because, as I said at the beginning, every single item that is interactive or that has a place in our game is a sprite. Okay, so we need to add a new sprite, and I'm going to do that from the library again. But again, if you want to paint it or upload your own file, you're more than welcome to. And from here, I'm just going to choose something that I think Scratch the Cat would eat. So Cheesy Puffs it is. Now, when I add this in here, again, just like with Scratch the Cat, I can drag Scratch around and I can position this wherever I need it to go. And then all of our motion blocks update. So right now I've got 0, 145. So I'm going to drag that over here. And I actually kind of want this to start off the top of the screen. So I'm actually going to go all the way up to the very top here to where my Y coordinate is 180. And I'm going to change that to 180. Just like with Scratch the Cat, we also need our when flag is clicked event so that we know when the game starts. That object should start at the top of the screen. And now we need to figure out a way to get that object to start falling from the top of the screen to the bottom of the screen. And this is probably, this part of the project is the single biggest issue that first-time coders run into. And all that is the translation of what you want your game to do into actual code. And Scratch is really good at this because we have these drag and drop blocks. We can be very explicit about how we want to do this, and it's pretty obvious what each block does when you start to move it. But we need to kind of break down that process. What is this actual object going to do? So in this case, our cheesy puffs are just going to fall from the top of the screen to the bottom. But what does that actually mean for this object? Well, realistically, what that means, if we're going to break it down into English, is that our cheesy poofs are going to change their Y coordinate, their Y position, from 180, which is at the very top of the screen, little by little, so one unit at a time, until they get down to negative 180 or whatever, spot we decide that they've hit the floor. Okay, so in plain English, our cheesy puffs are going to change their Y position from Y equals 180 down by 1 each time. Okay, so the basics here are that we're going to change our Y coordinate. So I'm going to grab this change Y block. And I want to change the Y position. Again, as you start going down, the Y position goes down by 1 until it's negative 180. So I want to change this Y position by negative 1. So each time we go through this, I want that cheesy poof bowl to drop down little by little by little, okay? But as we've seen, the computer does our steps in exactly the order and exactly the way that we tell it to. So if we just say when the green flag is clicked, go to this position and then change Y by 1, nothing seems to happen. Every time we click it, it just sits there. And that's because, again, it's done exactly what we told it to do. It went to that position and it changed the Y coordinate by -1, but it only did that once. So in order to get it to repeatedly do that, we need to introduce a new coding concept. So this is not specific to Scratch, but Scratch has a different way of showing this. And that's the control blocks. The control blocks are where you actually update and make the changes to an object. So we have a couple of them. We already dealt with one, which is wait 1 second. So again, maybe that's what we want to do. We want to change Y by 1, wait 1 second. And so, yep, that technically happened, but it's not what we wanted. We actually need these next blocks. We want it to either repeat a certain number of times or we want it to repeat forever. Now, one of the things that you'll learn as you start going through not just Scratch, but any programming language is that there's always more than one way to do something in code. There's multiple ways typically. There's never really a single right way. There's never really a single wrong way. You're going to find that you can constantly make things work in different ways. And so I'm not going to tell you which one of these to use to do what you want it to do, because you can either do a repeat that just repeats as many times as it needs to, and you can either type that in or figure it out, that repeats as many times as it needs to until Scratch the Cat gets to the bottom. So if we repeat this 180 times, we'll get from 180 to 0. If we repeat it 360 times, we'll go from 180 to -180. Or you can use this forever block. Okay, forever blocks basically just repeat this over and over and over and over once we click the green flag until we stop our program somehow. Excuse me. Until we stop our program. So if I click this and hit forever, and one of the things that you'll notice is that as I drag this into my block, if I've already got a block that's created, it'll highlight where it's going to position this. If I put it below, it'll just put it below. But if I put it above, it's actually going to wrap it around. So notice this is kind of a connected block. It looks like a cover. And then that whatever blocks I have inside of that will kind of snap into this forever block. So now if I hit my green flag, my bowl of cheesy puffs will fall 1 unit at a time. And notice how when we hit the green flag, that this code block that starts with when green flag clicked is highlighted in yellow. Okay, that means that our program is running this little series of blocks. Okay, if I hit the red, it's no longer highlighted in yellow. That means we've stopped it. If I hit the green flag again, it resets to what we said. Again, our recipe just starts from the top, and then it repeats this block over and over and over and over and over and over again. Okay. Some of the other control blocks that we have are our if-then branches, which we'll cover as we get into our program. But they basically are just our decision trees, which says if something happens, do this. If something else happens, do this. And we can combine these in different ways. And we're going to later on in this project. You can wait until something happens. You can repeat until something happens. So we're not going to do that for this particular part of our lesson, but we could do repeat until it touches the floor. So repeat until the Y position is 180. You'll notice there's a special little kind of empty gem looking shape here. We'll get to that. And then there's some other control blocks that we'll talk about a little bit later. But for now, our program basically does what we want it to do. Scratch the Cat moves left and right, and our cheesy poofs fall from the top of the screen. Okay. So now we need to put in the condition of what happens when Scratch the Cat actually catches our bowl of cheesy poofs. So we got about 10 minutes left in the first half of our training before we open it up for office hours. So we're going to add our first if-then block. And all our if-then block is going to say is if Scratch the Cat catches this bowl of cheesy poofs, we make it disappear off the screen. We're going to hide it off the screen. Okay, so the way that we do that is we grab one of these if-then blocks. And we're going to create it first before we insert it into our program. So I'm going to stop my program, and I'm going to see if I can figure out how exactly we're going to do this. So we need some criteria first. So the first thing that we need is to know where exactly our bowl of cheesy poofs should hit. So I'm going to say right about here. I don't care much left to right where it's going to go, and we're going to adjust that in just a little bit. But for right now, if it gets to about -115, I'll go even lower. We'll do -120. If it gets to -120, that means it's hit the ground because that's where Scratch the Cat is standing. So at that point, I'm going to assume that the player can't catch it anymore because it's hit the ground. Okay, so our condition will be if the bowl, if the object that we currently have highlighted has hit the ground, then do something. In this case, hide it, get rid of it, do whatever. Okay, so our first step is to figure out this little gem. And gems are basically your what we call Booleans, or your conditions. And conditions are essentially just whether or not something is true or false. So our block here is going to say if Scratch the Cat, or sorry, if the cheesy poofs are touching the ground, then do this. If they're not, then whatever we put inside here is not going to happen. We're only saying if something is true. And again, in terms of our recipe, we're going to go through those steps one at a time, and we're going to see how those work. So all of our conditionals, all of our math operations to determine if something is true or false are going to be in this operators section. Okay, and I'm intentionally going to introduce a mistake here, as I mentioned before, but hopefully you'll catch on to it as we kind of modify our game. So the first thing we're going to do is what condition do we want? And we determined that it was -120 was the spot where the cheesy poofs are, and we want to know when the cheesy poofs hit that 120 spot. Okay, so what we'll need to know is if the Y position of these cheesy poofs is equal to -120. Okay, and the way we do that is with these gem blocks. So notice how the shape of this block kind of clues you in to which pieces you can use in the middle here. So I'm going to grab this equals section because that's what we're checking for. We're checking to see if the Y position of our cheesy poofs equals -120. I'm actually going to type that in, -120 right here. So if the Y position equals -120, then do it. Now, it would be really cool if we could just type in Y position and it would automatically know what that means, but it doesn't. So Scratch actually has some special blocks that fit into these empty square spaces that tell us exactly what those properties are of the bowl. So in this case, our cheesy poofs, if we go to the motion section where we were controlling how it moves up and down, we have these little check boxes here, or not even check boxes. They're kind of pill shaped with check boxes to the left, but the pills say X position, Y position, and direction. Those are the three properties that each object or each sprite has. It has an X position, it has a Y position, and it has a direction that it's currently facing. Okay, so right now, both of our objects are currently facing 90 degrees to the right, and the X position and Y position are whatever we drag them. So in this case, our cheesy poofs right now are at 89, -121. So since we were checking the Y position, we can just drag that right into that spot. So right now, our if-then branch, our conditional, as we call it, which is what in programming concepts those if-thens are called. They're called conditionals because if a condition is true, then it causes something to happen. If not, then it won't. And so if the Y position equals -120, then we want to do something with that. Now, we could do any number of things. One of the things that we can do is we can reset that position back to that 0, 180. So that'll just start it right back up at the top, 0, 180. And if we insert this into our code so that it's inside that forever loop, then our recipe as we follow the steps is when we click the green flag, our cheesy poofs are going to teleport to the top of the screen here. And then until we stop our program, so forever, the Y position is going to change by -1. And if at any point following that change, the Y position equals -120, then it's going to zoom it right back up to the top of the screen. Okay, so as I mentioned, there's going to be an issue with this, but we're not going to see it. So first, we're going to run it as is. Then I'll introduce the problem with our current code, and then we'll go ahead and fix it for the last part of this session. So right now, if I hit the green flag, we should see exactly what we were seeing before. But now, once it gets to that -120 Y position, then it should jump back to the top of the screen. Okay, and it looks like that's happening. So the cheesy poofs are going down to the bottom of the screen. Once they hit the floor, boom, they shoot right back up to the top. Okay, now here's the issue with our current code. I'm going to speed up our cheesy poofs. Just like with Tetris and other games that people typically play where there's kind of like an infinite way to play. There's no ending really to the game itself. Our cheesy poof bowls are going to speed up as the game gets harder and harder and harder. So there will be more cheesy poofs on the screen at any given time, and they're going to move faster. So let's just pretend that we speed it up to -4. So now instead of changing 1 unit at a time, it's going to change 4 units at a time. So now if we start this, our cheesy poofs move much faster. Okay. And then let's go even faster and go to 5 now and start our program. Now let's go to 6. And at some point, as we start speeding this up, you're going to see the issue with our code. So again, this isn't even something that you would notice until you got farther in and the game was actually playing at this speed. Okay, so notice what's happening. I click the green flag, our cheesy poofs go, but then they go down to the bottom of the screen, and our block here is constantly being run. It never resets up to the top of the screen. Okay, the reason for that is because, as I mentioned at the very beginning of this session, Scratch will do, and any programming language will only do exactly what you tell it to do in the order that you tell it to do it. So what's happening in this particular case is we're changing the Y position by -7 and stopping this when it gets to -120, okay? Because we're changing it by 7, -120 is not a multiple of 7. So there is never a time where the Y position will ever equal -120 because it'll go 7, 14, 21, 28, so on and so forth until it gets all the way past negative 120 and keeps going. It will never actually hit a point where the y position equals negative 120. Okay, so at first glance, you might think, oh, well, then we can never have the speed be something that's not a multiple that evenly divides into 120. But there's there's an easier way to solve this issue, because we don't actually care. Again, if we break this problem down into English, we don't care if the cheesy poofs hit exactly 120. We just care if the cheesy poofs are on the floor. So what we actually care about, and if we go to the operators again, we don't care if the y position is equal to negative 120. We care if it's 120 or less. And actually, we don't even care if it's 120, because 121 or 122 will also be lower than that. So what we can do is use the less than operator. So again, that same shape, that ruby gem-shaped block has gem shapes here. So we're going to take our block and just change it. We're going to use the same y position and the same numeric value. Now we're just saying if it ever gets below negative 120. So now it shouldn't matter. It shouldn't matter if it's evenly divisible, because as soon as whatever that multiplication hits to get any lower than negative 120, it'll run that code to reset it. Okay. If you wanted to, you could make it equal to or less than, and in some cases you are going to need to double up on those. So again, we have these gems here below our comparison operators that say and, or, and not, and that just means we can take this gem and drag multiple gems inside of there to combine it. So it could be the y position is less than negative 20 and equal, which again would never happen, or the y position could be less than negative 20 or equal to negative 120. So however you want to do that, as long as it makes sense for the code that you're trying to write, you can use either of those. All right, we have one last thing to do for our training here, and this is basically going to be your homework. It's what we're going to work on during the office hours starting now. For those of you that have to leave at this point because your hour is up, that's totally fine. But your homework is to make it so that the cheesy poofs don't always start in the middle of the screen, okay? You're going to use blocks that we have not talked about. So I want you to kind of do some sleuthing and go through each of these different categories of blocks here in the middle and see if you can figure out a way to make it so that the cheesy poofs start at a random location from left to right. So it should be negative 240 to 240. You need to figure out a way to change our code here so that it's random between negative 120, or sorry, negative 240 and positive 240. Okay, so if you are following along from this point forward, I'm going to give you a little break, about 5 minutes, to see if you can find the answer to that. If not, then when I come back, we're going to go through and talk about that. So I'll be back in just a few minutes, and we'll continue from there. Just a reminder, if anybody has any questions or needs any help throughout the teacher training, feel free to message us on the YouTube live chat. You can also, after the fact, we are posting this on YouTube live, so it'll be available for viewing after the fact if you need to rewatch any part of it or do any recaps. You can also fill out our contact form on our website, sparkappleague.com/contact, and that'll go right to us, and we'll try to answer your question as soon as we can. You also have the ability to join our Hangouts. If you go to the teacher training page, sparkappleague.com/teacher-training, there's a link up at the top to join the Hangout, and there's also a link for the the YouTube live version of this video. Okay, so for those of you following along, our goal is to change our cheesy puffs or cheesy poofs so that when they fall from the top of the screen, they don't always fall from the immediate center of the screen. They're always going to start at the top of the screen, but we don't want it to always start in the immediate center here. We want it to just randomly kind of start from a position up here at the top. So the way that we're going to do that is if you did my suggestion or if you did your homework and you browsed through some of these screens, you might have seen some additional blocks here that'll help out with that. So I'm going to break this down from the beginning and just, again, walk through our recipe and see what part of this we need to change. So right now we're saying when the green flag is clicked, we're telling the cheesy poofs to go to x equals 0, y equals 180. Okay. X equals 0, as we talked about at the beginning here, is the middle of the screen. So that's the part that we want to change. We want to change the X coordinate. We want to leave the Y coordinate at 180. And the X coordinate, as I mentioned in my hint before we ended the first hour of today's session, we have negative 240 as the X coordinate for the left side of our stage and positive 240 for the X coordinate of the right side of our stage. So we need to get this X value to be a random number between negative 240 and positive 240. And again, if you took my suggestion and dug around, you may have found that the operators page has a pill-shaped block that says pick a random number between 1 and 10. And the 1 and 10 are fields that we can type into. Okay, so we're going to change those to say pick a random number from negative 240 to 240, and then we're going to drag that into our position block. If you remember too, we have 2 position blocks, so we also need to make sure that we adjust this and add that into there. So now our recipe says when the green flag is clicked, our cheesy poofs are going to go to a random X value between negative 240 and 240 and a positive 180 for the Y value. And then forever until we stop the program, we're going to change the Y coordinate. And I'm going to set this back to -1 since we fixed our previous issue. And then if it hits the ground or drops lower than -120, which is what we set as the ground, we want it to go to a random XY location and positive 180 back up at the top of the screen. So now we should see our cheesy poofs kind of start falling, hit the ground, randomly teleport to a location at the top of the screen, and then continue to drop down as we keep this running. So hopefully you guys can see that on your screens. If you're following along, hopefully your programs are doing the same. Now, what's interesting about the random number generator, the randomness, is that it truly is random. So sometimes you might get the cheesy poofs moving to a similar spot. Other times you'll get it to a completely different spot. It kind of runs the gamut. It is random, so it could go anywhere. And it looks like based on what we put in our work area, our recipe, it looks like it's doing just that. So it's starting from a random location left to right. It's falling down to the bottom of the screen. And then once it hits the bottom, it randomly teleports to another position up at the top. Okay, so that concludes our teacher training for week one. Again, as I mentioned before at the start of this, we will have another session on Wednesday and then another session on Thursday. The content of those sessions is going to be nearly exactly the same as this session. So we're only going to be learning about those basics. And then next week, we're going to start into some of that branching and some of the conditionals and some of the more programming focused logic. So today's intro on the actual Scratch interface is going to be repeated on Wednesday and Thursday, depending on what viewers and participants join in. If anybody asks questions, we might diverge a little bit, but I'll try to keep it as close as possible. Otherwise, as I mentioned, the YouTube link will be available on the teacher training page. We'll update that so you can click to rewatch at any time. And then next week, again, same time, same channel, we are going to continue on from here and actually add some logic into our game. So we'll determine if Scratch the Cat has caught the little bowl of cheesy poofs, or if it hit the ground. We'll add a system for lives and a system for points, and we should be able to do that all within the next session. So hopefully we'll see you then. I will be around for the office hours portion of this for another hour in this Hangout. We won't be broadcasting that portion though, so if you have questions, feel free to join the Hangout and ask them, and I will try to answer them as quickly and as detailed as possible. So thanks for joining us, and we'll see you at the next training session.